So combined heat and power. You've got something called a Stirling engine. So you've got two options. If you have, if you're in a power station and you want to generate electricity, generally what you have to do is to heat up water to produce steam, and then the steam drives the turbines. But then you have to cool the water through evaporation, which wastes about 50% of the energy that you use to heat it up, so it just gets evaporated into the environment. And then you then send it back through the power station to heat it up again and then drive the turbines. And it's that difference in power which will drive the turbines. So the difference in the temperature will drive the turbines. So if you take that water and instead of just trying to cool it in big cooling towers, you can send it to a nearby town, then you can produce what's known as a district heating scheme, and then it gets rid of all of its heat energy by producing heat in the radiators or the central heating systems of the people on the district heating scheme. Now, this costs an awful lot of money to move that hot water or steam, even small distances, in insulated pipework. However, these local heat generation, these central point heating generation plants, have become quite popular in Europe and in America. So if you've got a power station next to housing, that's the thing to do. However, very often you don't. And so, and it's the same goes for any industrial process which produces waste heat that you want to do something with. So what you can do is you can run that heat through what's called a Stirling engine, or other similar generating appliance. And that can turn it into electricity, and then you can distribute the electricity and sell that to the houses instead. Excuse me. Though you can produce combined heat and power on a much smaller scale in residential situations, and usually what it involves is having a diesel generator. The generator runs, it produces electricity for the property, and then it produces waste heat from the combustion. So you capture that waste heat and you put it through the equivalent of a little Stirling engine, and this then generates this. So this can either then be used to generate more electricity, or what you're more likely to do is to capture that heat by running water past the engine and its combustion products. And then that water goes into a heat exchanger, which then sends that heat off to your domestic hot water system. And so this is a more usual version. So your engine is predominantly producing electricity, and you're using that to power your house. The surplus heat generated by the engine gets used to heat up part of the hot water for your property. The alternative for this is micro combined heat and power, which are some very clever things we're starting to see in some of the new Baxi boilers. And so you can put these things inside your cold water plumbing system. And what they do is they have a teeny tiny turbine, and every time the water gets sent through the pipework, it drives this little turbine, or as the fans operate, it drives this little turbine. And that then produces a teeny tiny amount of electricity. You may think, what's the point of that? Well, the point of that is it saves some of the power you have to get from the national grid. Not all of it, but some of it. And that's generally what these things do. They supplement the national grid to reduce our needs.